Level 1. Comfortable. This is where the human body wants to live. Room temperature. Somewhere around 68 to 77 degrees Fahrenheit. In this range, your body barely has to work. No shivering, no sweating, nothing to compensate for. Your internal temperature and the air around you exist in a kind of truce. Your body doesn't have to fight for anything here. That's about to change. Level 2. Chilly. You reach for a jacket. Your blood vessels near the skin start tightening, just slightly, to hold heat in. It's called vasoconstriction. Blood gets rerouted away from your skin and back toward your organs. Your skin temperature can drop several degrees before your core notices anything at all. That gap is intentional. Your extremities are the first thing your body is willing to give up on. You don't notice it happening. Your body is already making its first small sacrifice to protect your core. Level 3. Freezing. This is the line where water turns to ice. 32 degrees Fahrenheit. Your body's response gets more aggressive here. Blood is pulled away from your hands, your feet, your ears, anywhere considered expendable. At the same time, your muscles start firing in rapid, involuntary bursts. Shivering. At its peak, shivering alone can push your body's heat production up to 5 times its normal resting rate. Your body has started deciding which parts of you matter most, and it's burning fuel fast to buy itself time. Level 4. Frostbite. At this level, the air itself becomes a weapon. At 0 degrees Fahrenheit with a 15-mile-per-hour wind, the wind chill drops to about -19. At that number, exposed skin can freeze in around 30 minutes. Push the wind chill down toward -40, and that window shrinks to 10 minutes or less. Below -75, it can happen in under 2 minutes. Ice crystals begin forming inside your own skin cells. First, it's numbness. Then the skin hardens. Then, it changes color. In the worst cases, the tissue dies completely and doesn't come back. Your body sacrificed your fingers and toes to protect the organs that keep you alive. Level 5. Hypothermia begins. Now, it's not just your skin. It's you. Normal human core temperature sits at about 98.6 degrees Fahrenheit. Once it drops below 95 degrees Fahrenheit, you are, medically speaking, hypothermic. Shivering. Confusion. Slowed reactions. This is classified as mild hypothermia, and it holds for a fairly narrow range, roughly 95 down to 89.6 degrees Fahrenheit. Inside that range, your judgment starts to fail before your body does. People in mild hypothermia have been known to make bizarre decisions, wandering further from shelter, removing clothing, insisting they feel fine right up until they don't. Below that window, your body enters new territory entirely. This is your body's last automatic attempt to generate its own heat. It won't be enough for long. Level 6. Severe hypothermia. Past this point, the shivering stops. That's not a good sign. That's your body giving up on generating heat at all. Between about 89.6 and 82.4 degrees Fahrenheit, moderate hypothermia sets in. Your heart starts beating irregularly, your pupils dilate, your breathing slows. Below 82.4 degrees Fahrenheit, hypothermia is classified as severe, and most people lose consciousness entirely. At these temperatures, the heart itself becomes dangerously unstable. Even slight movement or jostling can trigger a fatal arrhythmia. Doctors have a saying for patients this cold: you're not dead until you're warm and dead. Because at these temperatures, the human body can look completely lifeless, and still, sometimes, come back. Level 7. The Record. The record in 1999, a Norwegian doctor named Anna Bogenholm was skiing when she fell through ice into a frozen stream. She was trapped upside down, underwater, for 80 minutes. By the time rescuers reached her, her heart had stopped. When she reached the hospital, her core body temperature was measured at 56.7 degrees Fahrenheit, colder than any adult had ever been recorded and survived. Doctors worked on her for hours, slowly warming her blood outside her body. Here's the science behind why she lived at all. At normal body temperature, the brain can survive without oxygen for only about 20 minutes before permanent damage sets in. But cold slows metabolism dramatically. The colder your cells get, the less oxygen they need to survive. Because Bogenholm's body cooled before her heart actually stopped, her brain's demand for oxygen had already dropped far below normal. That single detail, the order things happened in, is likely what kept her brain alive long enough to be saved. She woke up. Today, she works as a radiologist in the very hospital that saved her life. Level 8. The coldest place on Earth. Now we leave the human body behind completely. Vostok Station sits more than 11,000 feet up on the Antarctic ice sheet, one of the most remote, isolated research outposts on the planet. In 1983, thermometers there recorded a temperature of -128.6 degrees Fahrenheit, the coldest temperature ever directly measured at ground level on this planet. Nearly 3 decades later, in 2010, Satellites detected an even colder reading nearby, around minus 134 degrees Fahrenheit, along a ridge between two ice domes on the same icy plateau. At these temperatures, exposed skin doesn't just get frostbite, it can freeze in seconds. Level 9, colder than the universe itself. Here's where it gets strange. Deep space has a temperature too. Leftover heat from the Big Bang, still glowing faintly across the entire universe, at about 2.725 Kelvin, roughly minus 270.4 degrees Celsius. But there is one known place colder than that. The Boomerang Nebula, roughly 5,000 light-years away, is a dying star ejecting gas outward at more than 600,000 kilometers per hour. That expansion happens so violently fast that the gas cools rapidly as it spreads. The same principle that makes air from a spray can feel cold on your skin, just scaled up to a cosmic level. Its temperature sits at around 1 Kelvin, nearly minus 2072 degrees Celsius. It is, as far as we know, the single coldest natural place that exists anywhere in the cosmos, colder than empty space itself. Level 10. Absolute Zero. This is the floor. Absolute zero sits at minus 273.15 degrees Celsius. 0 on the Kelvin scale. At that point, in theory, all atomic motion would completely stop. Here's the part that should unsettle you. According to the third law of thermodynamics, we can never actually reach it. Not ever. Cooling something down always requires removing energy in steps, and each step gets harder than the last. Reaching true zero would take an infinite number of them. But scientists have gotten unbelievably close. In a laboratory, researchers cooled a cloud of rubidium atoms into a Bose-Einstein condensate, then dropped it 120 meters in freefall to cancel out gravity. The result, matter cooled to within 38 trillionths of a degree of absolute zero. That's roughly 5 billion times colder than the Boomerang Nebula. Colder, in that instant, than anywhere else in the known universe. Here's what's worth remembering. Heat is just motion. Atoms and particles vibrating, colliding, moving. Cold isn't really a thing at all, it's the absence of it. And it turns out, getting to true nothingness might be the one boundary the universe never lets anyone fully cross.